Okay, so this is limit definition of the derivative. Okay. Derivative. Okay, so we have quite a few vocab words today. Okay, and they're all sort of connected. Once we get through the vocab, we'll sort of draw some pictures to help us with that understanding. Okay, so limit definition of the derivative. There goes. All right. First thing we're going to do is define derivative. Okay. Which is an equation that describes hold on, I can make that clearer. There we go. Okay, that describes the slope of the tangent line. Like, okay, but I don't know what a tangent line is. Right? We're going. So it does connect to geometry a little bit. An equation that describes the slope of the tangent line at any point. Okay. So our next piece is, I'm just going to highlight, okay? So derivative, right? I'm going to go with orange next, okay? So tangent line. So we use the word tangent line here, so that's the next thing that I'm going to define. So tangent line. Okay, tangent line right is the equation of a line. Okay, so when I say tangent line is the equation of a line, I mean like algebra 1 equation of a line. Okay, so that would either be y minus y1 slope x minus x1, so that's point slope form, or mx plus b. That's what I mean when I say equation of a line. Okay, the equation of a line that touches f of x at one point. Okay, so the tangent line, yes, connects to geometry. So I'm just going to draw a little circle, and I'm going to think way back to what a tangent line looked like for a circle. It's where it just barely touches that one point on the edge of the circle. That's what you called a tangent line in geometry. Same thing, except we don't have this kind of picture. We have like polynomial type graphs now. Okay? So when I draw the picture of this tangent line, okay, it's going to look like, okay, put a point. All right. Imagine that you're looking at the edge of a circle. Draw a tangent line. Okay, so it just barely right? Just barely touches that point in one spot. Yes.
The definition is the equation of a line that touches f of x at one point.
Yes.
Okay, so I wasn't sure if what we were talking about.
Oh, yeah, no, I was just giving room for the formulas. Okay. Now, I'm going to pick another point. Let's say right here. Okay, and I'm going to draw a tangent line. And so I'm going to just sort of cover up the other parts of the graph and just kind of envision it as a circle and draw that tangent line just barely touching the edge of that point. All right. And I know that these arrows keep going and you're like, but like, wouldn't it touch somewhere else? It might. So when I say touches one point, I really mean in this little area right there, right at the point in question, it's only touching once. Okay, don't look too far out. So right here, this is the point on the graph that is only touching at one spot. Okay, so tangent line is the equation of a line that touches the graph at one point. Okay, now up here we had slope of the tangent line. So that's what we're going to do next. Okay, tangent slope. Tangent slope. Okay. I'm just going to make this one pink. Okay. Because, right, these things, right, these words are kind of being used in that first definition, which is why I'm defining them as we go. All right. Tangent slope. The slope of the tangent line. Okay. So I'm going to write down, right? So tangent line touches at one point, slope of the tangent line. So what I want to do is write the equation of slope. But I'm going to write down the 1 point. Okay, so we have 1 point. This is x and this is y. Here's the other point, which is the same point, right? Because 1 point. And we're going to start with slope tangent. Okay, well, my slope formula is the same one as it's always been. Okay, right? But if I want it to be the tangent slope, I'm just going to use the same point. Doesn't seem right. Doesn't work. I get 0 over 0. That's an indeterminate form. It means you don't actually know what it is. It's not undefined. It's not 0. It's not 1. It's I don't know yet. I don't know yet. Okay, so indeterminate. Indeterminate means we have to try harder. Because it didn't work. Okay. last thing I'm going to say here before I give you a little visual of the words that we've described here, okay, is I'm going to go up here and I'm just going to add a little notation underneath of derivative. And it's F prime. It looks like an apostrophe. It's not a 1, it's slanted. It's a prime of x. And we say it F prime of x. And I'm putting it here next to derivative because they're interchangeable. Okay, the derivative is f prime of x. One of them is a word, one of them is notation. When you say the prime, that's how you get that little slash up there. Okay. Any clarification on these words before I give you the visual? All right, here comes the picture. Okay. Okay, here we go. So notice right here, I've got a graph that's in blue. We'll zoom in just a little bit. Ooh, okay, not too far. All right, and you've got the red line, which is the tangent line. So notice the purple dot there. So I'm going to just move it. Okay, so the red line is the tangent line. Notice that the red line does happen to touch the graph in more than one spot sometimes, but look at the purple dot. At the purple dot, that's where it's only touching once. So think about that little section right around the purple dot. That's where it touches once. Don't look too far out. Okay, that's the tangent line. Right? Could have a negative slope, could have a positive slope. Could have almost a 0 slope. Okay, can you find the slope of this tangent line? Yeah, you can. You ready? Super tricky. Well, I think I'm going to count from here. Oh, to here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the slope at this spot, notice that I counted dots on the red line, is positive 6 over positive 5. So the slope is 6 over 5. The slope of this tangent line is 6 over 5. Guys, you've already learned everything there is to learn about lines. All I did is add that word tangent in front of it. You do know how to find the slope of a tangent line. You look at it and you count. Okay?
So we're only looking at the red line.
You're only, yeah, because I said the slope of the tangent line, which is the red line. So let's pick a different spot. Okay, gotta wait for it to come back into view. Oh, keep coming, go back. Zoom out just a little bit. Woo, okay, there we go. Wait for it to come back into view. Okay. Why does it, there we go. Okay, that's a good one. So I'm gonna zoom in just a little bit so I can see it. Okay, and I'm going to count the slope. There we go, of the red line. So when I'm counting slope, I'm looking at the red line and I'm looking for points that are easy, like they're on the grid marks, and I'm looking to see where. Okay, look, grid marks. Okay, that one looks pretty good. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8, 1, 2, 3, 4, 5, 6, 7. So the slope at this point is 7/8. Notice that I'm touching the red line when I count the slope, not the blue line. I'm touching the red line, which is the tangent line. All right. So now I have another picture for you. Which is this one here. Hold on. Okay. Let's do this. Okay. So this is a graph where I have 2 points on the line. This is called a secant line. Secant line touches 2 points. Okay? Now, what I want to do is figure out, okay, notice that it kind of looks like a tangent line if I put my 2 points really close together. Okay, so let's move it around. Notice that when I have 2 points really close together, that it sort of looks like the tangent line as it moves across the graph here. Okay? I can even get the points really close together, and it really looks like the tangent line. Okay, so we're gonna pause in just a minute. Wait for it to come back. Okay. Secant line. 2 points on a curve. As I move the points closer together, closer, 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 what happens as I move the points closer and closer together? Okay, 0.01, 0.001, 0.000. Oh, too close. Tangent line. So as you move the 2 points closer together, it turns into the tangent line. That's what we're going to do algebraically. Okay? So let's flip back to your notes. I'm going to flip my page because I'm out of space. And we're going to write 2 more definitions here. All right, secant line. Secant line, okay, is line through 2 points on the graph. Okay, seems pretty reasonable. 2 points on the graph. All right, secant slope. Okay, secant slope. Slope of the secant line. All right, so secant slope has 2 points. So I'm going to write 2 points here, and we're actually going to write down the formula for secant slope. So one of the points is f of x, okay? See that? X and y. The other point is just some distance away from that. So I'm going to say x plus h, right? H is how far apart the points are. The y coordinate is just this. So I have 2 points. H is the distance between the points, how far apart they are. Okay, so let's just formula. Slope secant. Y2 minus Y1 all over X2 minus X1. Difference quotient? That stuff you did in your homework? Okay, notice that in the denominator, the x's actually do cancel out. So slope secant equals f of x plus h minus f of x all over h. That's the secant slope. But we're more interested in tangent slope because that's really what calculus is about, is the tangent slope. Okay? All right, so we're going to turn secant slope into tangent slope. So we're going to say slope tangent equals. Now, in order for this to turn into tangent slope, the points have to move together. The limit as the distance between the points goes to 0. Okay? Remember, h is the distance between the points. If I make the distance 0, the 2 points have actually turned into 1 point. Okay, I'm going to put a little box around this because that is sort of the culminating information from all of those vocab words we did. The tangent slope is defined by that limit statement. Now I'm going to put a couple more words in here. I'm going to say derivative equals the limit, as I'm just copying the limit statement, right? Because we have a couple words that are interchangeable that mean the same thing. Okay? The other, okay, f prime of x. Okay. F of x plus h minus f of x all over h. Okay, so these three words, these are all interchangeable, right? I could say find tangent slope. What is the derivative? What is f prime of x? They all mean to find the same thing. Is, right, just an example. And we're going to do f of x equals x squared plus 3x. Okay, so this is what I want you to graph on the graph. I don't need you to graph it by hand. Calculator, Desmos, doesn't matter. Now, I do suggest that instead of counting each block by 1, I would relabel it so that you have kind of like a zoomed in picture. Right, so there's the origin. Okay. Okay. Go. Okay, so when I graph this, I'm not graphing it by hand. I'm just, okay. All right, there you go. Boop. Okay, so I graphed it in Desmos, and I'm just transferring it onto my paper. Okay, this is the equation. Whoop. See, I typed it in, and this is what I'm graphing. All right. So I'm just going to pick a few key points. Or 0, 0 looks pretty decent. -3, 0. Okay. I'm looking for like integer coordinates because those are easier to graph. Okay, so -2, 2 seems like a pretty decent point. Okay, so -2, 2. Okay. Oh, this one looks pretty good. Right, parabolas are symmetric, so -1, -2. So, and I'll click on the vertex, which is 1.5 there, and just a little less than 2. Okay. Just try to get the general shape. Pretty good. Doesn't have to be perfect. Just, okay. All right, so little wobbly, but I've got the basic shape here. Right? You're not going to have to graph by hand. You can always use some utility to help you get the pictures. Okay. Question. Find the derivative of f of x. Find the derivative. Okay. Find f prime of x. Okay, so derivative is the key word, right? Remember, those two things are interchangeable. They mean the same thing. So I'm going to write down that thing we put in the box at the end of our notes. That's what it is. Okay. F prime of x equals the limit as h approaches 0, f of x plus h minus f of x all over h. Okay. That's the thing that we put in the box. That's the formula on how we find the derivative. Okay. Difference quotient. This is the difference quotient that we've been practicing evaluating in your homework. Okay, so I'm going to work on this part. Okay, I'm not to the limit yet. I'm just going to try to figure out how to make this and this go together. So I need the f of x plus h. Here's f of x. All right. F of x plus h is when you plug in the x plus h. Okay, notice this is the f of x. This is f of x plus h, where you plug that in. All right. Okay, so now that I have this, okay, f of x is this part here. Those are the two pieces. So now that I have them, I'm going to put them into my difference quotient. Yes. Is it what? Yes, yeah. The x squared is what makes it the parabola shape. Okay, here we go. Difference quotient. X plus h squared plus 3xh minus all over h. Okay, well, I think I'm going to work on my multiplying and combining like terms before I put that divide by h in there. Okay, so x squared. Okay, I'm hoping the practice you've been doing is making it easier to follow what I just did. Yes? Okay, here's my difference quotient. Okay, so this part here is this part. Okay, this part here is this part. Does that make sense? Yeah. Okay. This is good. Ask the questions, guys. Because there's two things happening here. There's a lot of algebra. Foiling, factoring, combining, reducing. But there's also the setup. Make sure that you know where the different pieces are coming from. Because right now I'm not explaining the algebra. I'm explaining how to get from this limit statement and how to evaluate the limit statement. Why that limit statement is the derivative. Okay, let's combine up these like terms. Okay. Yes, I like to square and circle my like terms. Okay. Ooh. Factor out that h. Okay, factor out that h. Yay! Almost there. Okay. Now, notice that this was just me working on the difference quotient. So I do need to bring in this part here, f prime of x equals the limit as h approaches 0. How do I evaluate a limit statement after I factor and reduce? Flowchart, what do you do after you factor and reduce? Plug in again, direct substitute. Awesome. Okay, when you do the direct substitution, the limit goes away. So we get 2x plus 0 plus 3. Right, because I did 0 plus 3. That's what I did. Put a little box around this. You found the derivative, which is an equation that describes the tangent slope. That's what it is. Okay. You're almost there. We're going to look at the point negative 2, 2 on the graph. Right there. That's the point we're going to look at. This equation describes the tangent slope. So right here, f prime of negative 2. All right. The x-coordinate equals 2 times negative 2 plus 3. Okay, now f prime notation is kind of messes me up a little bit sometimes. So I'm going to switch it to slope tangent because that's what it is. Remember, those words are interchangeable. F prime is interchangeable with saying the tangent slope. Okay, so the tangent slope at this point, at that spot on the graph, is negative 1. Okay, hopefully you have a straight edge of some sorts near you. Okay. Put your ruler on the graph. Make it look like a tangent line. Right? So you can kind of move your ruler around a little bit like a tangent line, but you want that dot right at the point 2, 2, negative 2, negative 2. Okay? And see if you can make your ruler do a negative 1 slope. Does it look good? Now, we all draw graphs with a little bit of error because it's not perfect. Okay, so I'm going to try to, okay. So there's my visual of the tangent line that I used the equation to find the tangent slope. So right here, the point is negative 2, negative 2, and the tangent slope is negative 1. I mean, look at the count. Like, you can actually see the slope is negative 1 on that graph. Yes.
So did you just choose that point?
Yeah, because they're integer coordinates.
Okay.
Yeah. Just as an example to show it visually how sort of like this big picture all connects. Because sometimes a tangent line, you're like, yes, it looks like that. But like, where does all this algebra match? Okay, so we're going to pick the origin, and we're just going to do the same thing. We're going to look at the origin. That's this point right here, which is another integer coordinates on the graph. And we're going to find the tangent slope, and we're going to see if it matches. Okay, so f prime of 0 equals, and I like to say slope tangent because it makes more sense to me to write down what I'm actually finding. Okay, because remember, those things, right, f prime and tangent slope are interchangeable. Then I get a slope of 3. Then I take my straight edge up to my graph, and I see if a 3 slope actually seems to match. Right, straight edges are pretty useful. So does that work? It looks pretty good. Yeah, that looks pretty decent. So the point is 0, 0, and the slope tangent is 3. Oh, that's hard to read. I'll fix that.